Welcome to homework.
This is a more conceptual problem involving quantum dots. We are told that the lifetime of an energy transition is relatively long. So we have a delta t that's 10 nanoseconds, but they consider that relatively long. And we're asked some questions about the spread of energy of our emitted photons when it's in some state. Given some options, delta E is either A, more well-defined because of delta T being big, less well-defined because of delta T being big, not affected by lifetime at all, and no spread in energy regardless. So we have four options. We have to uncover which one's true. So it'll become immediately obvious which one's true once we think of this in terms of a Heisenberg uncertainty principle involving energy and time. So we all know that Heisenberg uncertainty principle can relate momentum uncertainty and spatial uncertainty. It's greater than or equal to some minimum value. There's also a second Heisenberg uncertainty principle, which is just a re-expression that some uncertainty in energy, some spread in energy, multiplied by some spread in time, has some minimum uncertainty that relates them. The product of these is some constant. So if we're assuming that delta t is large, we can immediately see what the consequence will be for delta E by moving it over to the other side. So if delta t is big, that means that delta E is going to be really small. So by having a very, very long lifetime, the spread in energy is going to be more well-defined, not less well-defined, and definitely not completely independent. So if I had to guess, and I think it's a pretty strong suspicion, I'm thinking it's this one right here. I think it's A. These energy levels are going to be more well-defined because of the long lifetime due to the Heisenberg uncertainty principle. And that's really, I think, the idea of this problem.